6.2. So 9 years ago, a bank granted Mandy a home loan of 525,000 rand. This loan was to be repaid over 20 years at an interest rate of 10% per annum, compounded monthly. Mandy's monthly repayments commenced exactly 1 month after the loan was granted. So immediately when we see a home loan and it's consistent payments to repay back the loan, that automatically tells you that this is referring to a present value annuity. So Mandy decided to make monthly payments of 6,000 rand instead of 5,066 and 36 rand. How many payments will she make to settle the loan? So firstly, let's write our present value formula from our data sheet. And we know that our value that we are repaying back is 525,000. Our interest rate is 10% compounded monthly, or you can even write it as 10% over 12. And our time frame, well, that's what we need to calculate. I mean, although it's overpaid over 20 years, but if she's making payments more than like almost just under 1,000 and more than she's supposed to, then that is what we need to figure out. So on top of that, we know the X amount, which is what she's making. They told us here in this question here that she is making 6,000 rand every month. Okay, so we in agreement that what we're working out is how many payments, which is added here. So let's go ahead and sub in our values. 525,000 is equals to 6,000. To the power minus n, which is what we want to work out. And then our interest rate at the bottom, which is 10 over 1,200. So ideally, let's cross multiply and then divide by 6,000, and then we get something of the sort of 35 over 48. So if you take 525,000 times by 10 over 1,200 divided by 6,000, and then thereafter we are left with, because now we need to isolate our unknown, which is our n, and that in this instance is 1 minus into 1 plus. Just to simplify this, let's make this 0.1 over 12 to the power minus n. So again, when there is unknown exponents, that means that we are going to be using logs. All right, so after we get to that, then thereafter we can go ahead and make this entire part that we're working on positive, just to make our lives a bit easier. And what I'm going to do is take that onto one side and take the new having 48 onto the other side. So it's going to be 1 plus 0.1 12 to the power n to the power minus n, sorry. And then we make that positive, we make that term which holds the unknown exponent positive, and then we take this and we minus 1 minus 35 over 48. And thereafter, what we can now do is now we can use our logs to work out what n is. So really minus n is equals to log, and I'm just going to leave this exactly as is, 1 minus 35 over 48, and base 1 plus 0.1 over 12, just so there aren't any errors and aren't any rounding off unnecessarily before our final answer. So this would keep the accuracy, and ideally we should get a negative answer here, and then the two negatives will cancel since payments would have to be positive, right? So we get minus n is equals to 157.40, and therefore n is equals to 158 payments. So if you wanted to figure out how much faster this would take her as opposed to the 20 years, we just need to take the number of payments and divide it by 12.